Yes, good afternoon all my dear students. Yeah, hope all of you are fine, doing well. And first of all, a very all the best for the students who are writing the KCET exam today. All the very best, do your best. Okay. So students, today we'll be discussing about the another organic chapter. Yeah, now we have covered almost like 3 to 4 organic chapters. Now this is the another organic chapter, haloalkanes and haloarenes, that we will be discussing today. Okay, and one of the beauty of organic chemistry is more the number of organic chapters we will be covering, the easiest it will be. That is the beauty of organic chemistry, because most of the reactions, if you observe, it will be very common. It will be very common in all the chapters, because the reaction that we have seen in hydrocarbon, you can see in aldehyde ketones, you can see in phenols, you can see in haloalkanes. So that is the main important thing in organic chemistry. So it is going to help you a lot. So as we have discussed lot of organic chapters, this is not going to be a big chapter for you. Most of the reaction we have covered, especially in the hydrocarbon chapter. So this is not going to be a big or difficult chapter for you. Already we have covered a lot of things. Okay, so if you are ready for everything, we can start the class. Shall we start the class? Sakshi and Sanjay, shall we? Are you guys ready? Yes, thank you. Okay, first of all, we can go into the important topics. Already I am going to tell you, already I have mentioned all these topics in the previous classes. The important topics, that is, first is about the method of preparation of haloalkanes. Okay, first is from alcohol, and the first method of preparation is by using the Lucas reagent that we already have discussed in the previous classes. Then PCl3, PCl5, SOCl2, all these things already we have discussed by mock test discussion or through some chapter also. Now next is from hydrocarbon, this already we have covered in the hydrocarbon chapter itself. That is free radical halogenation of alkenes, electrophilic substitution of arenes, Sandme's reaction, all these reactions we have covered already, right? So that is why I am saying the organic chapter more you are covering, the less content will be in the upcoming chapter. Okay, and so already as we have discussed all of these things, I am not going to revise it once again, because no need of doing it again and thereby wasting the time. We can directly go to the questions and all. Now next is by the alkenes. From alkenes, how we can prepare alkyl halate. First method is addition of hydrogen halate, Markov-Nikov rule, that we already have discussed, and anti-Markov-Nikov rule. All these we have discussed in the hydrocarbon chapter. Now next one, addition of halogen, that is test for unsaturation. Then halogen exchange. The halogen exchange method is the method of preparation of alkyl fluoride and alkyl iodide, which we haven't discussed. And the reactions are Finkelstein reaction and Schwartz reaction. So we will be discussing each and everything one by one. Okay, now the another important one is the chemical reaction of alkanes is a very important one, that is the substitution, nucleophilic reaction and the elimination reaction. These two are the important one in which we will be going in deep. Okay, now the last one is polyhalogen compound. I am adding here because some informative questions can ask from this part. So that already I have mentioned in the slide, you can just copy it and you can study. That's only the thing. Okay, so these are the important topics that we will be discussing today. Yeah, we'll be starting from the beginning. First is about the method of preparation. The method of preparation first is from alcohol. From alcohol, how we can prepare? What is the first method of preparation? Alcohol with HX, that is with the hydrogen halate. That is, if I am taking alcohol ROH, I am treating it with HBr. What is going to happen? Here the OH, which is a nucleophile, and bromine, which is another nucleophile, they will be substituting, and what we will be getting? I will be getting RBr plus H2O. This is the easiest way you can prepare alkyl bromate. Okay, now instead of HBr, in some of the questions they can also give ROH NaBr plus H2SO4. ROH, they will be treating it with NaBr plus H2SO4. Don't get confused. This reagent will be giving HBr, and the final product is same only, RBr plus H2O. So don't get confused. It is some different reaction. Both are same. Okay, another one is ROH plus hydrogen iodide. For hydrogen iodide also same thing, but I will be getting RI plus H2O. We will be getting the same thing. Okay, we'll be getting alkyl iodide. Okay, now here also there is a thing that is ROH. If I am treating ROH in presence of potassium iodide and H3PO4, what I will be getting? The same thing. Here this reaction with the Ki and H3PO4, they will give hydrogen iodide and we will be getting the same product, Ri plus H2. So that is one more thing, one more point you have to note it down. Instead of directly giving hydrogen halide, they can indirectly give the hydrogen halide and can ask the product. Yes. Okay. Okay, shall I move? Have you got it? Now the one more point is ROH, which I am treating with what? Which I am treating with HCl. If I am treating alcohol with HCl, what is the product we are getting? What is the product we are getting? Here we won't be able to substitute it directly because HCl is not that much reactive. HCl is not that much reactive, so because of that we will be using a Lewis acid. In the presence of Lewis acid, this reaction will be taking place, that is RCl plus H2O, and this reaction we already have discussed it in the previous chapter, that is Lucas reaction or Lucas, and the reagent is Lucas reagent. Okay, these are the important point how we can prepare alcohol from hydrogen halide. Is it clear, Sakshi?
Yes, sir.
Okay, thank you. Just note it down all these points. And the rate of reaction for hydrogen halide, rate of reaction already you know, right? It is following tertiary greater than secondary greater than primary because it is following SN1 mechanism. Okay, that is the alcohol that you will be taking should be tertiary, then only the reaction will be forming immediately or faster. Okay, now yes, now in presence of PCl3, PCl5, how we can produce alkyl halide? Okay, if I am taking alcohol ROH plus PCl3 or PX3, anything we can do it. Okay, here also same thing, substitution will be taking place, that is OH will be replaced by chlorine, RCl. OH will be replaced by chlorine. Now along with the RCl, what is the other product that is forming? That is the important one, because there was a question about the byproduct that is forming when alcohol react with the PCl3. What we have to do is, whenever PCl3 or PX3 react with the oxygen containing substrate, what is the byproduct we will be getting is, we will be getting H3PO3. We will be getting H3PO3, and instead of PCl3, if I am taking PCl5, I will be also getting RCl, and the byproduct you will be getting is POCl3. So this is the point you have to note down. Byproduct H3PO3 and POCl3. And now one more reaction is that alcohol on treating with the SOCl2. Alcohol on treating with the SOCl2 in presence of pyridine. In presence of pyridine catalyst, here also I will be getting RCl. Along with the alkyl chloride, I will be getting SO2 plus HCl, and both are gases. And this method of preparation of alkyl chloride or alkyl halide in presence of SOCl2, we will be calling it as Darson's process. Just note it down. And this is one of the best method of preparation of alkyl chloride, because the product that we can see, they are gaseous product. Gaseous product will immediately be eliminating, and which results in the forward reaction. Okay, is it clear? Is it clear, Sakshi? Shall we move? Yes, thank you. Yes, next is from alkene. From alkene already we have discussed in the hydrocarbon chapter. You can go through it and you can have a understanding of it. Okay, anyhow I will be just telling, it is completely following Markov-Nikov rule. That is, I already said the Markov-Nikov rule. What it is? Alkene on treating with the hydrogen halide, the hydrogen will be attaching on that carbon where there is more number of hydrogen. Okay, if I am just taking RCH double bond CH2, hydrogen will be adding to that carbon where there is more number of hydrogen, and halogen will be adding to that carbon where there is less number of hydrogen, and resulting in the formation of RCHX CH3. and we got an alkyl halide. And remember that there will be a carbocation rearrangement. Here there will be carbocation rearrangement. Only after checking whether the carbocation is stable, then only you have to add the halogen. That is the point you have to note down. Okay. Next one is anti-Markovnikov rule or peroxide effect. Peroxide effect is very easy. What we have to do, there is no need of checking carbocation rearrangement. What is according to peroxide effect? Hydrogen will be adding to that carbon where there is lesser number of hydrogen. Hydrogen will be adding to that carbon where there is lesser number of hydrogen. Or halogen. Halogen here we will be using only HBr. The reagent for peroxide effect is only HBr. That is only HBr will be giving the peroxide effect reaction or anti-Markovnikov rule. Okay, and the bromine will be adding to that carbon where there is more number of hydrogen. If you can see that also. CH2 HBr in presence of peroxide. But you can see where there is more number of hydrogen, there bromine will be attaching. That is RCH Br CH2. So here I got a primary alkyl halide. In the above case we got a secondary alkyl halide by the two method of preparation. One is through Markovnikov rule, another one is through anti-Markovnikov rule. Okay. Now one more point we have to note down is anti-Markovnikov rule or peroxide effect or Karash effect. Effect will work only on unsymmetrical alkene. If the alkene is unsymmetrical, then only the peroxide effect will be working or is applicable. Because for symmetrical alkene, there is no need of checking the number of hydrogen in the carbon and all are same. We can add anywhere. So it is specially working for unsymmetrical alkenes. Okay. So this is the point I want to take a note of it. Is it clear? Is it?
Yes, sir.
Yeah, okay. Any doubt do you have? No, right? Okay. Yes. Next one is halogen exchange method. This is the method of preparation for iodine and alkyl fluoride. Normally in the normal method of hydrogen halide addition, we can't prepare alkyl iodide and alkyl fluoride. The reason is alkyl iodide, it is very slow or it is reversible reaction, so it is very difficult to produce alkyl iodide. And alkyl fluoride, the fluorine is very much reactive, so there also we can produce alkyl fluoride. So these are the two methods in which we can prepare alkyl iodide and alkyl fluoride. First one is Fingerstein reaction. Here just it is a halogen exchange method. Halogen exchange method means this halogen, it is replaced by the another halogen. So this halogen is replaced by iodine, so I got alkyl iodide in presence of sodium iodide and the solvent is acetone. In presence of sodium iodide and the solvent is acetone. I remember that this halogen, the halogen that we will be using should be chlorine or bromine. The halogen that we will be using for chlorine, bromine and will give reaction only for primary and secondary alkyl halide. That is the alkyl halide that we are taking. It should be either primary or secondary alkyl halide because it is following through SN2 mechanism. This exchange is happening to SN2 mechanism because we know that SN2 mechanism, it will be favoring less sterically hindered carbon. Okay, the same thing for Schwarz reaction, the same thing, that is X should be chlorine, bromine and the metal fluoride. This will be taking in presence of metal fluoride, and the metal fluoride that we will be using is AgF, any metal which is having the fluorine, and AgF then HgF2, they will be giving alkyl fluoride. And apart from AgF or HgF2, other metal fluoride that is giving Schwarz reaction, that is also has asked in the NEET exam, that I will be giving. Other metal fluorides giving Schwarz reaction. Other metal fluorides giving Schwarz reaction. What is Which are the other metal? Sb F5, As F3, Sb F3, CO F2. These are the other metal fluids we can get Schwarz reaction. Hg2F2, Hgf2, all these are the other metal fluids in which we can give Schwarz reaction. Note down the other metal fluids also, it can also ask in the exam. Okay, have you got the complete idea about the preparation reactions of alkyl halide? Yes, okay. Just take a note of it, everything. We will be moving to the next. Yeah, next is chemical reactions of haloalkanes. This is the important one, chemical reactions of haloalkanes. First one we will be discussing about the nucleophilic substitution reaction. Nucleophilic substitution reaction. In that I will be discussing SN1 mechanism first. SN1 mechanism. What is SN1 mechanism? Substitution nucleophilic unimolecular reaction, which means here order and molecularity both are same, that is 1, and as it is a unimolecular reaction, the rate depend upon the concentration of substrate only. Rate depend upon concentration of substrate. Okay, occurs in two-step mechanism. It is a two-step process. Two-step process. Okay, and this is happening through carbocation intermediate. Carbocation intermediate will be forming in between the reaction. Okay, and as the carbocation intermediate is forming, you have to check for rearrangement. You can check for the rearrangement. Okay, then what are the other points? Sakshi, you know about SN1 mechanism? What about the solvent? What type of solvent we can use here? Any idea? Two types of solvents are there, polar protic solvent as well as polar aprotic solvent. Which solvent will be favoring nucleophilic unimolecular reaction? Polar protic solvent. Polar protic solvent favors the reaction. And what type of nucleophile will be? Whether it is strong nucleophile or weak nucleophile. Which nucleophile will be favoring SN1 mechanism? Strong or weak? Any idea? Sakshi or Chester? Strong or weak? Which nucleophile will be? Yes, which nucleophile? Stronger one. SN1 is favoring stronger one? Are you sure? Weak nucleophile favors the SN1 mechanism. Why weak nucleophile? Because here we need to form carbocation. We need to give time for the alkyl halide to form carbocation. Only weak nucleophile can give time for the alkyl halide to give carbocation. If I am using strong nucleophile, the carbocation won't be forming. It will be directly attacking on the carbon, and it will be moving into the substitution in a single step. That's why we are using weak nucleophile. Yes. Now any other points? You want to add here about the SN1 mechanism? What about the stereochemistry? What about the racemization? Is it forming complete racemization? Are we going to get a inverter product or retention product? Inversion or retention, or 50% of both?
Racemization.
Yeah, racemization, that's very good, but theoretically it is racemization. And my question is whether it is complete racemization or there is a partial racemization. Complete or partial? Any idea? Yeah, here also you will be doing some mistakes. Here there is no complete racemization. Complete racemization is theoretical only, but practically there is not complete racemization. That is, there is no complete 50-50 inverted and retained product. Okay, actually there is only partial racemization, and which will be preferred is inverted product. Okay, practically it has been observed that the preferred product is inverted product only than the retention product. Okay, that's another point you had to note out. Yes. And now one more point I want to say generally to the nucleophilic reaction, they are exothermic reaction. They are exothermic. As their exothermic reaction, they are take place in high temperature or low temperature. Take place in high temperature or low temperature. Chesta, Sakshi, if it is exothermic. Any idea? This we discussed in the chemical equilibrium chapter. Takes place in? Come on.
High temperature.
High temperature. Exothermic means it is happening by releasing of heat. If I increases the temperature, it will goes in the backward direction, no, because heat is releasing in the product side. If I am increasing the heat or if I am increasing the temperature, the product side will increases, which will lead to the backward direction. So it will be take place in low temperature. Okay, so these are the point I want everyone to take a note of it, that is SN1 mechanism. And now we will be going to some examples of SN1 reaction. Have you noted down all these points? All are important points. Question can ask from any of these things. Shall I move? Students, shall I move to the next? Have you noted down? Yes, thank you. Okay, now we can go through some of the examples. Okay, I am just taking CH3, CH2. Yeah, I got H2O here, and H2O is a nucleophile I am going to give, and CH3OH. What is the product I will be getting in both the cases? What is the product? What is the product? In the first case, what is the product? In all these cases, the first step is the formation of carbocation CH2 plus. That is by the elimination of the halogen. That is the leaving group. And here also same thing, CH3, CH2 plus. Okay. Now next step is the attack of the nucleophile. What is the nucleophile forming in H2O and what is the nucleophile forming in CH3OH? In H2O, what is
Nucleophile OH minus.
Yes, very good. OH will be the nucleophile here. Actually, water only. This lone pair will be attacking on the CH2 and will be forming a protonated alcohol. And that on stabilization process, it will be attacking on it will be leaving the proton CH3, CH2OH. Now what about the second one? That's my question. CH3OH. Second one. What is the nucleophile that is forming here, or that is attacking or replacing the halogen? Come on.
OCH2.
Yes.
OCH.
Oh, CH. Yes, very good. Yes, very good. That's the thing. Here, what is happening? This lone pair will be attacking on this one and resulting in the formation of CH3, CH2, CH3, CH2, O, OH, CH3, and here the oxygen will be getting a positive charge. To stabilize this positive charge, the hydrogen will be leaved as proton and resulting in the formation of CH3, CH2, O, CH3, CH3. Yeah, this is the product. Yes, very good, very good. Okay, now few more questions I want to give you. CH3, CH3, CH2, Cl in presence of water, H2O. What is the product you will be getting here? This is a substitution nucleophilic unimolecular reaction. What is the product you will be getting here? Where the OH will be substituting?
Tertiary alcohol.
Yes, very good. Here we will be getting a tertiary alcohol. Why we are getting tertiary alcohol? Because here the carbocation will be undergoing rearrangement. This is the carbocation. This is secondary carbocation, right? And they can change into a tertiary carbocation through what? Through hydrogen shift. 1 to hydrate shift and resulting in the formation of CH3, CH3, and here the OH minus will be attacking. CH3 OH. Yes, that is we got a tertiary alcohol. Yes, got it? Got the complete understanding?
Yes, sir.
Okay, very good. One more question. Yeah, here is another question for you. Yeah, what is the product that is forming here? Here cyclopentyl alkyl halide. What is the product you can form here? Yes. Sorry. Just give me a minute. Am I audible? Is my voice clear? Sakshi, Chesta, yes, thank you. Okay, what is the product? Anybody got the idea? Here one point you have to note down is about the carbocation. Yeah, that is first step is leaving group. Leaving group will be leaving. That is what I will be getting. Yeah, here CH2 plus. I got a carbocation here. I got a carbocation here. And here is the point you have to do is whenever a carbocation is attached to a strained ring, whenever carbocation is attached to a strained ring, there will be ring expansion. There will be ring expansion will be taking place. So how the ring expansion will be taking place? Here this bond will be breaking and they will be catching the carbocation. They will be catching this carbocation and the carbocation will be changing to the adjacent carbon, resulting in the formation of a 6-membered ring. The 5-membered ring has changed to 6-membered ring with a carbocation here, and then the nucleophile will be attaching and resulting in the formation of a cyclohexanol OH. Note down the point when halogen when carbocation is directly attached to a strained ring, then ring expansion will take place. Okay. Now another point. When carbocation is present in a strained ring, then ring contraction will take place. This is the two important points you have to note it down. This also I will give an example. That is, I am just attaching a halogen to a cyclobutane, and what is the product that you will be getting? What is going to first step is the formation of carbocation, in which you can see this carbocation is present in a strained ring, right? Whenever this carbocation is present in a strained ring, at that time there will be a ring contraction. How the ring contraction will be taking place? This bond will be breaking and they will be attaching on this carbocation. They will be attaching on this carbocation, which result in the formation of a cyclopropyl methyl cation. That is, this carbocation will be comes and attached to this carbon, and that is what I have mentioned with this one single line. Okay. And cyclopropyl methyl cation is exceptionally stable cation. It is an exceptionally stable cation because of dancing resonance. What is dancing resonance? It is a shifting of the sigma bond, which result in the formation of a double bonded product in this cyclopropyl butyl alcohol. cyclopropyl methyl cation. Okay, because of the dancing resonance it is stable. And here on adding OH minus, what I will be getting? I will be getting OH here. So these are the two important points, ring contraction, ring expansion. You have noted down for the carbocation rearrangement. Take a note of it or take a screenshot. All are very important. Got it? Any doubt anybody having regarding this? All the points we have covered. Is it clear? Any doubt? Sakshi or Chesta? Any doubt do you have? If you have, I can clear it, or else we can move into it. Okay. Okay. Now one more point is, whenever there is a carbocation present on a bridge head, this is what bridge head position. If I am seeing a this is bridge head position, or if the carbocation is present in an aromatic ring, in both the cases they are very unstable due to the lack of planarity. This carbocation is not belongs to the same plane, and here also this carbocation, it is not present in the same plane. It is perpendicular to the sp2 hybridized carbon atom. Because of that, there won't be any delocalization. Delocalization will take place only if both the vacant orbitals or both the p orbital will be in parallel to each other. So these are the other few points you have noted down. Complete things about SN reaction has been mentioned here. Take a note of it and try to solve the questions. Okay, done. Are you clear about all these things? Shall we move to the next, that is SN2 mechanism or SN2 reaction? Shall we? Give me some thumbs up, some reactions. Didn't understand? Anybody want me to repeat it once again? No, right? Shall I move? Shall I move, students? Okay. Yes. Now next one is SN2 mechanism. SN2 mechanism. SN2 mechanism, what are the important points here? Order is equal to molecular activity is equal to 2, as it is a bimolecular reaction. Yeah, and here the rate is directly proportional to the rate of the reaction. Rate of the reaction is directly proportional to K into concentration of substrate and nucleophile. Concentration of both substrate and nucleophile. That is why it is second order reaction, and it will be taking place in presence of polar aprotic solvent. And here it is a single step process. Takes place via transition state. Then any other points? Do you want me to add for SN2 mechanism? If you are remembering, just let me know. What are the other points I can add for SN2 mechanism? What about the yes, very good. Strong nucleophile. Thank you. Strong nucleophile. Favors the reaction. Why we need strong nucleophile? Because we need to take place this reaction a single step. Single step reaction will take place only if I am giving a strong nucleophile. Okay. Then any other points? What about the stereochemistry? What is the product we will be getting here? What about the product we will be getting? Yeah, inverted product. And this inversion we will be calling it as Walden inversion. We'll be calling it as Walden inversion. Okay. Any other points? No, right?
Primary till secondary term.
Yeah, that are the factors affecting that we will be discussing after giving one example. Okay, factors affecting for both SN1 and SN2 that we will be discussing after giving an idea about both the things. Okay, now yeah, we can just go through a small reaction, that is This is alkyl halide. This is alkyl halide. If I am treating it with the water, or if I am treating it with a strong nucleophile, and just this is a nucleophile and this is a strong nucleophile, this will be attacking from the back side. As it is attacking from the back side, and this halogen will be removing, and this attacking and the removal of halogen will be taking place in the same time. It is taking place simultaneously, and that process which is in between will be leading to a transition state. I can just tell you the transition state. That is OH. OH will be partially making bonds with the carbon. And halogen will be also making a partial bond with the carbon. They both will be in a state to, OH will be in a state to attach to the carbon, and CX will be in a state to leave from the carbon. And this is a transition state, and a 5-membered triangular bipyramidal 5-membered transition state. And as a result you can see the OH will be attacking here. Yeah, we got the product. Okay, this is the simple reaction of SN2 mechanism. Okay, are you done? Always attack is from the back side. Okay, this is all about the SN2 mechanism or SN2 reaction. Now we can go into the factors affecting SN2 mechanism as well as SN1 mechanism, that we can go in detail. Shall I move, students? Have you taken the note of it? Yes. First we can move into the factors affecting SN1 mechanism. First one is the rate of the reaction is directly or inversely proportional to the bulkiness. Directly or inversely proportional to the bulkiness of alkyl halide. Bulkiness of alkyl halide, because more bulkier alkyl halide only will be giving more stable carbocation, that is tertiary greater than secondary greater than primary, then 0 degrees Celsius. That is tertiary alkyl halide will be giving the SN1 reaction very faster comparing to the remaining degree alkyl halide. Okay, now next one presence of, okay, I will be giving you a substrate CH2 double bond CH2X. Okay, one, two, three, four. Okay, now tell me for in this case whether rate will be higher or lower. If a halogen is attached to CH double bond CH2, in this case the rate will be higher or lower? That's my question. Rate is higher or lower?
Lower.
Rate will be, yes, very good, it is lower. What is the reason? Because the lone pair present in the halogen will be involved in the will be involving in the delocalization with the conjugated system, and which results in making a partial double bond character here. If there is a partial double bond character between carbon and halogen, what is going to happen? The breakage of carbon halogen will not take place easily, which will decreases the rate of reaction. Now the third one, CH2 double bond CH2X. In this case, tell me, 2, 3. In this case, tell me whether the rate will be higher or lower.
Higher.
Yes, very good. It will be higher. What is the reason? What is the reason? What is the reason? Rate of SN1 reaction is directly dependent upon the stability of carbocation. If the carbocation that is forming is stable, here the carbocation is stabilized by resonance. In this case, the rate will be higher. Rate increases. These are the 2 points you had noted down. Okay, one more point is there. In this case, tell me, in this case whether rate will be higher or lower. In this case, CH3 or CH2X, rate is higher or lower? or rate increases or decreases? Tell me quickly, fastly. Rate increases, very good, because here also the same thing. CH3O CH2 plus, the carbocation that is formed will be stabilized by the back bonding. The lone pair of electrons in the oxygen will be back bonding to the vacant orbitals of carbon, and which will be increasing the rate. Increase the rate. Okay. Now one more point. Presence of electron withdrawing group. Presence of electron withdrawing group. If I am attaching an electron withdrawing group, CH3, C double bond O, CH2X, this will be increasing the rate or decreasing the rate? Another question. Increasing or decreasing the rate? Tell me, guys. Decreasing. Sure. Yes. Very good. What is the reason? CH3, C double bond O, CH2. Here the carbocation that is formed, this is minus M. They will be withdrawing electron, which will increase the magnitude of this positive charge. If the magnitude of positive charge increases, the stability will decreases and rate decreases. So these are all the important points that is affecting the factors that is affecting the SN1 reaction. Take a note of it completely. Question can ask from any of this point. Just give me a minute. Students, am I audible to you? Hello?
Yes, sir.
Okay, is it clear? Screen, everything is fine?
Yes, sir.
Okay, thank you. Okay, now we can move into the factors affecting SN2 mechanism or SN2 reaction. Yes. SN2. Okay, tell me the factors affecting the SN2 mechanism or SN2 reaction. What are the first factors? What about the bulkiness? Rate is directly or inversely proportional to the bulkiness? Inversely, very good. Inversely proportional to the bulkiness of alkyl halide. Because of that, the rate is higher for primary alkyl halide than secondary alkyl halide than tertiary alkyl halide. First will be 0 degree, then primary, secondary, tertiary. And note down, tertiary alkyl halide won't give SN2 reaction. Won't give SN2 reaction. Tertiary alkyl halide majorly it will be running through SN1 mechanism. Okay. Then any other point? Any other point, students? What about the electron deficiency? Rate is directly or inversely proportional to the electron deficiency of carbon. Electron deficiency of carbon. Rate is directly proportional to electron deficiency of carbon. As it is single step process, nucleophile will be attacking on the carbon if it is higher in electron deficient. So I can say the rate is directly proportional to the electron deficiency of carbon. So if it is directly proportional to the electron deficiency of carbon, what about the presence of electron withdrawing group? Presence of electron withdrawing group increases or decreases?
Electron and make carbon electron deficiency.
Exactly, that's a point. That is, electron withdrawing group will be increasing the carbon's electron deficiency, in which it can easily attacked by nucleophile. Presence of electron withdrawing group increases the rate. Yeah, example I can give. CH3, CH2X and NO2. In the first case or second case, which one the rate is higher? In which case the rate is higher? First one or second one? Second one is rate higher, because NO2 is a strong minus M group, right? We all know. As it is a strong minus M group, this will make this carbon more electron deficient. And here it is CH3 only. This is an electron electron donating group, it won't be making it that much electron deficient. Okay, so the rate is higher. Yes. Any other points? Any other points? Okay. Now if I am talking about the stereochemistry, for SN2 mechanism or SN2 reaction, you have to check for the stereochemistry, because the product that you will be getting is inverted product. If the carbon in the alkyl halide is a chiral carbon, then you have to check for the stereochemical product, that is inverted product. Example, if I am giving you a reaction, bromine is attaching here, just a minute. I am attaching a bromine here, which is in the front side, and a hydrogen here, and it is happening through KCN, that is SN2. Okay, what is the product here? In this case, what is the product? You have to write the inverted product. If you see that carbon is, if you see that the carbon is a chiral carbon, then you have to check for the inverted product. How we can write the product? Here the bromine is in the position of bromine is towards observer, but in the product you have to substitute the CN, in which the position of the new nucleophile will be away from the observer. And this is how you can write the product, inverted product. Got it? If the bromine is in the towards observer, then the substituted product, that is CN, should be away from the observer. That is the point. Got it? Clear? Is it clear? Yes. Now one more question I want to give. What is the product that is forming here? What is the product that is forming here? My question is, who will be substituted by CN? Who will be substituted by CN? That's my question. Chlorine or bromine?
Chlorine.
Chlorine. Why? Why chlorine? Why not bromine?
Because it is SN2 reaction, and by removal of chlorine, a primary is formed.
Okay, yeah, it is SN2, and not only in this SN2, in both SN1 and SN2, we already have discussed that if the lone pair is in here, if the lone pair of halogen is in partial or forming a partial double bond character here, because of that this bromine won't be removed easily. The first and main step in all the nucleophilic reaction is leaving group has to leave. Leaving group won't be leaving if it is forming a strong bond with carbon. So here the bromine is involving in the partial double bond character here, so it won't be leaving easily. So chlorine, which is not involved in any of that things, it can be easily substituted. So the product will be chlorine substituted by CN. That's the main point. Okay, so these are the important points of SN2 mechanism or SN2 reaction. Just go through it. Yeah, the complete idea about both nucleophilic reaction I have mentioned here. And one more thing is that rate of both SN1 and SN2 depends on the ability of leaving or the leaving tendency of leaving group. Depends on the leaving tendency of leaving group. And what is the order of leaving tendency of halogens? Iodine will be having highest tendency to leave because it is making a very weak bond with the carbon, then bromine, then chlorine, then fluorine. This is same in the case of both the reaction, SN1 and SN2. Got it? Clear? Shall I move? Okay, yes, thank you. Now we can move into the next one, that is elimination reaction. Yes, this is just a comparison of SN1 and SN2, first order, second order, carbocation, transition state, all these things we have discussed. Okay, Next is elimination reaction or dehydrohalogenation reaction. Okay, first of all, before going into the E1 and E2 reaction, first I will be discussing E1. I want to tell you this is an endothermic reaction. Endothermic reaction, and it will be taking place in presence of in presence of temperature. Okay, as it is taking place in presence of temperature, elimination reaction will be favored in presence of heat. So first of all, E1 reaction, it is similar to SN1 reaction, and here the nucleophile will be acting as base and weak base will be favoring the reaction, and here order and molecularity both are same, that is 1. Okay, and this is endothermic that you already discussed. As it is similar to SN1, it is follows carbocation rearrangement. So these are the important points. Any other points? Did I miss? It is also called as beta elimination because halogen from the alpha carbon and hydrogen from the beta carbon is eliminating. Halogen from alpha carbon and hydrogen from beta carbon will be eliminating. Okay, yeah, this is the complete idea about E1 reaction. Now we can just go through what we can go through. We can just go through the comparison. If I am just giving a alkyl halide CH3 CH2X CH3OH nucleophile I am giving, and this is taking place in presence of 60 degrees Celsius. Another one CH3OH which is taking place in presence of 20 degrees Celsius. What is going to be the product in first case and second case? In first case, I have taken a CH3OH that is in higher temperature. Second case, I have taken CH3OH in lower temperature. What will be the product in the first one and second one? Just guess it if you are not sure about it. Yes, Sakshi, what is the product in the first one? That is following is elimination reaction or substitution reaction? First one.
Elimination.
First one, elimination. Very good, because already I mentioned if I am taking the same nucleophile in higher temperature, that will be following elimination reaction, and if it is a lower temperature, that will be favoring substitution reaction. That is how you can differentiate SN reaction and elimination reaction, because both are look same. In the second case, in lower temperature, this CH3OH will act as a base. In the first case, at higher temperature, in the second case in which CH3OH is in low temperature, it will be acting as a nucleophile, and the first case in higher temperature, this will be acting as a nucleophile. That's the point. Yes, now we can write the product. Elimination reaction, it is alpha beta. Hydrogen from the alpha position and one hydrogen from the beta position will be eliminating. Okay, and what I will be getting? I will be getting the alkene. CH2 double bond CH2. Second case it is elimination. Second case it is substitution. CH3 CH2 O CH, that is O CH3 will be substituting. Got it? Got the difference between SN reaction and elimination reaction? Is it clear, Sakshi? Do you have any doubt? You can ask me, no worries. Clear, right?
Yes, sir.
Yes, thank you. Okay, and it will be following same as that of SN reaction, that is carbocation rearrangement, everything will be undergoing. Okay, now the point is E1 reaction follows Say's rule, that is more substituted alkene or alkene having more alpha, alkene having more alpha hydrogen, alkene having more alpha hydrogen is the major product. In the case of E1 reaction, always the major product is Saytzeff rule, but in the case of E2 reaction, because of some conditions, some reason, it is following in some cases it is following Hofmann product. That I will be discussing in the E2 part. Okay, note down this one. Saytzeff rule, you know, right? Already we discussed it in the hydrocarbon. Do you want an example? Do you need an example of Saytzeff product and Hofmann product?
Yes, sir.
Okay.
Example.
Yeah, I can give an example. CH3, CH2, CH2X, sorry, CH3, okay. Okay, now look at here. Yeah, I am adding water into it. I am adding, yeah. Sorry,
Valency of third carbon.
valency of third carbon, 1 2, okay, it is. Okay, I will be giving a new one. CH3, CH2, CHX, CH3. Okay. Now it will be taking place in presence of high temperature, and what is going to be the product here? Here you can see this is alpha. It is alpha beta elimination rate. This is alpha position and there is a beta position here. There is a beta position here. Okay. Now first step is carbocation rearrangement. CH2 C plus CH plus H plus. Okay. Now this is secondary carbocation. This is a stable among these. Now what is going to happen in the next step? There will be beta hydrogen elimination. And how many beta hydrogens are there? There are two types of beta hydrogens are there. This is one beta hydrogen. This is another beta hydrogen. And elimination of one beta hydrogen will be giving which product? If I am taking, sorry, this is beta, right? Just a minute. Okay. Okay. Yeah, this is beta carbon, this is beta carbon. Okay. Now the elimination, this is one beta hydrogen. Here there will be, if I am, this is beta 1, this is beta 2. If I am eliminating this beta 1 hydrogen, what is the product I will be getting? CH3, CH double bond, CH and CH3. Now if I am eliminating the beta 2 hydrogen, if I am eliminating beta 2 hydrogen, what is the product I will be getting? CH3, CH, CH, single bond, CH2, CH, CH2. So this is the two product I will be getting. If I am taking this beta hydrogen, then I will be getting a double bond in between these two carbon. Now my question is, among these, which is major one and which is major one and which is minor one? That you have to check for the Saytzeff product. How we can check that one? Among these, which is having more alpha hydrogen? Here how many are? This is alpha. This is with respect to this double bond. This is the alpha carbon. So 2 alpha hydrogen. And here how many alpha hydrogens? 3. Yeah, 3 plus 3, that is 6 alpha hydrogen. So more number of alpha hydrogen means that is what type of product? Saytzeff or Hofmann? Saytzeff or Hofmann? What about the first one? What is the name of this product? Hofmann or Saytzeff?
Hofmann.
Yes, very good. It is Hoffman product. The second one is Saytzeff product, and the Saytzeff product is the most stable one, or this is the thermodynamically stable one. It is major one, and this is minor. This is same in the case. It is same all the time in the case of E1 reaction. Got it? Have you understood this example? Okay. Yes. Thank you. Now we can move into the E2 reaction. E2 elimination. Okay. Yeah. E2 reaction, it will be follows second order kinetics, and as it is following second order kinetics, rate is equal to K into concentration of substrate into concentration of base. Single step. Then strong base favors a reaction. Strong base favors a reaction. Any other points? These are the important points, and now we can go through what are the reagents. Yes, what happened? Yeah, that's important. Exothermic, no, all the elimination reactions are endothermic. All the elimination reactions are endothermic, and nucleophilic reactions are exothermic. Elimination, how we can differentiate whether it is undergoing elimination or substitution, or whether the nucleophile acts as a nucleophile or a base, that depends upon the temperature. In the higher temperature, it will be taking place, or the reaction will be proceeding through elimination mechanism. In the case of lower temperature, reaction will be proceeding through substitution mechanism. Okay, it is endothermic. Okay, now the point is, it's very easy only, E2 mechanism. The point you have noted down is the reagents. Which are the reagents that will be favoring the E2 mechanism? The major reagent in which you have seen in lot of mock test and in the exams, that is alcoholic, hot alcoholic, KOH or ETO minus, that is ethoxide, or ETOH, that is ethanol. Okay, then apart from this, NaNH2, that is strong base. Strong base always favors E2 elimination over E1 elimination. NaH2, NaOCH3, NaOC2H5, these are the some of the strong bases which is favoring E2 mechanism. Okay, got it? Now apart from this, potassium tertiary butoxide, O minus, or potassium tertiary butoxide in tertiary butyl alcohol. So these are some of the reagents that will be favoring the elimination reaction, E2 reaction. Yes, got it? Yes. Now we can check for the factors affecting. Is it clear? Shall I move? Shall I? How we can understand elimination reactions? Elimination E1 reaction, we can understand whether if the reaction or if the reagent is taking place in water or in alcohol. Like if the reaction is taking place, or if the reagent is taking place in presence of aqueous medium, then they will be following E1 elimination, which will be going through carbocation rearrangement. And if it is not in water, it will be acting as a strong base, and it will be going, or it will be doing the reaction in through E2 mechanism. Okay, is it clear? Yes. So here also the product obtaining is Saytzeff is the major product. Saytzeff is the major product. but in some cases Hofmann will be the major one. That cases I will be discussing. I will be discussing the case in which Hofmann is going to be the major one. If the leaving group is a poor leaving group, example like fluorine, we know that a rate of elimination reaction or rate of substitution reaction both depend upon the ability, the leaving tendency of leaving group. That is, poor bases are good leaving group, poor bases are good leaving group. If the leaving groups are very poor or if the leaving tendency is very less, then in that cases Hofmann will be the major product and Zaitsev will be the minor product. Next one is, if the base is bulkier, like potassium tertiary butoxide, like that. If I am taking a tertiary butyl alcohol or potassium tertiary butoxide, in that case the base is bulkier, it will be following Hofmann product. Now third one, if the substrate is bulkier, in that case also it will be following the Hofmann product. Okay. And the last one is, if the substrate contains gamma quaternary carbon. If the substrate containing gamma quaternary carbon, what is meant by gamma quaternary carbon? What is it? Gamma quaternary carbon, that is CH3, 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 CH2, CH2X. For this substrate, if you observe, this is the alpha position, this is the beta position, this is the gamma position, and in the gamma position you can see it is quaternary, the carbon is quaternary. In this case also the product that is forming here, will be giving Hofmann as a major one. Okay, I am just putting halogen here. See, this is also beta one, and we can see the product CH3, C, CH3, CH3. Okay, now if you observe the product, if I am taking the hydrogen from this beta carbon, what is the product I will be getting? There will be a double bond in the alpha and beta one with the removal of halogen, then CH3, 1, 2, 3, hydrogen. Okay, this is the product, and this is, we know that it's a more substituted alkene, and this is Zaitsev product. And another product what we will be getting, that is CH3, C, CH3, CH3. That is, if I am taking alpha and beta elimination, beta 2 elimination, what is the product I will be getting? CH, 2, CH double bond, CH2, and this is Hofmann product. Now among these, which is more stable? Sakshi, tell me, Hofmann or Zaitsev? No, what I mentioned, here I have mentioned the points. Which cases Hofmann will be the major one? Which are the cases in which Hofmann is the major one? If the substrate contains gamma quaternary carbon, that is, here you can see the substrate having a gamma quaternary carbon. In this case, the Hofmann is going to be the major product and Zaitsev is going to be the minor product. Because the base, if I am taking base, the base has to take proton from this carbon, right? But because of the bulkiness, the base can't easily take the proton from this carbon. That is why the Hofmann is going to be the major one. If the base take hydrogen from this carbon, Zaitsev is the major one. But that taking is not an easy process. It's a difficult process because of the presence of this quaternary carbon or the bulkiness. Okay, that is why we are getting the Hofmann as a major one. Taking base from this beta carbon is very easy because there is no repulsion due to the bulkiness. Got it? So these are the points you have noted down in the case in which the Hofmann is going to be the major one. Clear?
Yes, sir.
Yes. So this is a complete idea behind elimination reactions and substitution reaction. This is a very important part in this chapter. This chapter is all about these two things. Okay, we have to mainly focus on substitution reactions and elimination in this chapter. Remaining things are already coming as a common thing in many of the other organic chapters. So you will be automatically covering it. Yes. Now just give one example. Alcoholic KOH. What is the product obtaining here? Alcoholic KOH, it will be giving which reaction? Elimination reactions or elimination or substitution?
Elimination.
Elimination, very good. And what is the product you will be getting here?
Tertiary alcohol.
Tertiary alcohol, are you sure? But I won't get any reaction. I won't get any product here. Why? There is no beta hydrogen. No beta hydrogen. If there is no beta hydrogen, then how the reaction can occur? That is also the another point you have to be very conscious while writing the elimination product. If there is no beta hydrogen, then you should not do the reaction. Got it? Clear? Shall I move? Is it clear, Sakshi? Yes, thank you. Now this is all about now the difference between elimination E1 and E2 that I have mentioned already in the slides. So this is for your reference. If you want, you can take a screenshot of all these things. Do you want to take screenshot? Because this annotation probably won't be available because of some problems in my slide. Do you want to take the screenshot? Just take a screenshot. Okay. Take the screenshot of this also. Take it. Done. Yeah, this also you can take it. Factors affecting SN2. Done. Are you done? Okay. Factors affecting SN1. Okay. Now this one already you have taken or not? Okay, take it, or else no issue. All the videos are uploading in the YouTube. If you have any doubt, you can go and refer it and you can get the clarity. Okay. Elimination reactions and substitution both are over. Yes. Just an idea about substitution elimination. Always you have to think that aqueous KOH, if it is aqueous solution, that will be giving substitution over elimination, and if it is alcoholic KOH, that will, most of the questions you can see alcoholic KOH, that will be giving elimination over substitution. Okay. And high temperature always favors elimination over substitution. This is how we can differentiate whether the reaction undergoes elimination or substitution. Okay. Now the another point is the nucleophilic aromatic substitution. That is, if I am taking haloalkanes, if I am taking haloarenes, this is haloarenes. Haloarenes just generally won't be giving the substitution nucleophilic reaction. What is the reason? Because it's all about leaving ability. We have to leave this leaving group, then only substitution will take place. But this lone pair will be involved in the delocalization. Because of that, there will be partial double bond character. So normally there won't be substitution reactions in the case of haloarenes. Okay, it will be very difficult, or the reactivity will be very low. That's only the point here. And also phenyl cation, the phenyl cation that is forming here, that we already mentioned, phenyl carbocation, that will be very unstable because of the lack of planarity. Yes. Okay, next is reaction with metal. This already we have discussed, that is Wood's reaction.
Product we can get.
Sorry. Yeah, but what you are asking, Sakshi?
Sir, by dialuminum product we can get fluorobenzene.
Yeah, through diazonium salt we can prepare fluorobenzene. Diazonium salt we are preparing, how it is preparing, that is through aniline only, right? Aniline on treating with NaNO2 HCl under low temperature, we will be getting diazonium salt, and the diazonium salt is not that a stable compound, that can be easily converted to fluorobenzene through Bart-Schiemann reaction, and then chlorobenzene or bromobenzene through Sandmeis reaction or Gattermann reaction, that we already have discussed. But direct elimination or substitution of haloalkanes is difficult because of the partial double bond character. Got it? Yes. Now the reaction with the metal, already we have discussed Woods reaction. What is Woods reaction? What's the Woods reaction? If I am taking 2 molecules of alkyl halide in presence of Na alkyl halide, I will be getting R plus 2 NaX. And what is Fittig reaction? We discussed it in the hydrocarbon chapter. Fittig reaction, I will be taking 2 molecules of aryl halide C6H5X aryl halide plus Na in presence of dry ether. What I will be getting? I will be getting 2 aryl compound, diphenyl compound I will be getting. That is Fittig reaction. Fittig reaction is preparation of diphenylarane. And what is Woods Fittig? Woods Fittig means I will be taking 1 molecule of alkyl halide and another molecule of aryl halide C6H5X dry ether. What I will be getting? The alkyl group will be, the radical forming in alkyl group will be attaching with the radical forming in aryl group, that is R plus 2 NaX. This is what the reaction with metals. Woods reaction, Fittig reaction and Woods Fittig reaction. And one more reaction is there that we discussed in the hydrocarbon chapter, that is Franklin reaction, in which you will be using, instead of sodium we will be using zinc as the metal. Clear? Just take a screenshot, it's already we discussed, that's why I am not going much into it. Preparation of alkane with a even number of carbon. Okay. Woods reaction, everything we discussed. Okay. Fittig reaction or okay. Now the last part of it, that is polyhalogen compound. Polyhalogen compound, it is an informative type of question can ask from the exam. That is 3 important polyhalogen compound: chloroforms, iodoform and freons. Chloroform, just note it down. Chloroform, it is majorly used for depresses central nervous system. It is a poisonous gas. It will be depressing the central nervous system. Chronic exposure causes liver kidney damage. And point the note down, your note down is oxidizes to toxic phosgene. Chloroform can oxidizes to toxic phosgene, and phosgene is a carbonyl chloride. Phosgene is what? It is a carbonyl chloride. The common name of phosgene is carbonyl chloride, COCl2. Chloroform on oxidizes, we will be getting a poisonous gas, that is COCl2, phosgene. Now iodoform normally it will be using for antiseptic because of the liberation of iodine that is happening there. It is having an unpleasant smell. The betadine solution that we are using when we got an injury and all, that is all liberating iodine and will be acting as an antiseptic. Then freons. Freon gases, just note down the freon gases, they are refrigerants. In the refrigerators we are using this freon gas, and aerosol propellants, freon 112. And it is extremely stable, migrate to upper atmosphere and causes ozone depletion. The gas that is reason for ozone depletion. These are the informative questions that can comes from this part. Just note it down. That's only. Okay. So this is all about this chapter. Every point, each and every single point I have completed in this chapter. Now we can go through some PYQs. Shall we go, Sakshi? PYQs, if you look, are very easy questions only. You can solve it by your own itself. Okay. Now the first question. Just now, go through it. Is it clear? The screen is visible? Give me the answer for the first one. Yeah. The compound which is treating with the Grignard reagent CH3MgBr, and excess of Grignard reagent is I am adding. Then on treating with H3O+, what is the product we are getting? As we are taking excess of Grignard reagent, it can attack on this carbonyl carbon as well as this nitrile carbon also. So what is the product? First of all, just go through the mechanism. Grignard reagent, this lone pair, this negative charge in the CH3, they can attack on this carbon and they will be moving to, the bond will be shifting to the oxygen, or this will be attacking on the carbon and the double bond will be shifted to the nitrogen. And what is the product we are getting? COMgBr with a CH3, then C double bond N MgBr with the CH3. Now this on hydrolysis, we know that what is the product forming here. This OMgBr will be converted to OH group. OH, CH3, and this C double bond NMgBr, they will be completely converted to C double bond O, carbonyl group, CH3. So this is the final product. Just note it down. Are you done? Shall I move to the next question, or any doubt in this question? As we are taking excess of CH3MgBr, it will be doing reaction to both the carbon. Okay, that is nitrite group will be converted to the carbonyl group, and the carbonyl group will be converted to the alcoholic. That's only the thing. Now the next one, CH3CH2Br, alcoholic KOH, HBr, then aqueous KOH. What is the product that you will be getting? Yes, note it down. What is the product? First of all, alcoholic KOH in presence of temperature. What is the product you will be getting, students? What is the product? Is it substitution or elimination? Substitution or elimination?
Elimination.
Yes, very good. It is elimination. So the first step we can say CH3 CH double bond. What is the answer?
Option B.
Option B. Very good. I hope you got it. Now here the confusion thing is that here is aqueous KOH and temperature is mentioned here. Normally we already said that in presence of temperature it will be following elimination reaction, right? Elimination reaction. But here here it will be going substitution reaction because it is aqueous KOH, and also you won't be getting confusion in this because there is no product here in which elimination is taking place here. So we can directly understand that this is substitution here. Okay, so do you want me to solve it? It's an easy question, right? Shall I move?
No, sir.
Okay.
Yes.
Yeah. Now another question. The following reaction method is not suitable for the preparation of corresponding. Which one is not suitable? Which halogen is not suitable for doing this? That is this substitution reaction. Not electrophilic aromatic substitution reaction. Which one? Fluorine, iodide, chlorine, Br. Because of the high reactivity. Among these, which halogen won't be doing this reaction?
Fluorine.
Yes, very good. We all know that fluorine is a high reactive one. So that won't be doing this reaction. Moving to the next question. The compound that will undergo SN1 reaction with the fastest rate. SN1 reaction only, is the screen is visible?
Yes, sir.
Okay. SN1 reaction. In which case SN1 will be moving very faster?
Option 2.
Option 2. Are you sure? SN1 reaction rate is directly proportional to what? Stability of carbocation. Among these, which carbon can form a stable carbocation? That is going to be my answer. That is, stability order is tertiary greater than secondary greater than primary. And if there is an allylic carbocation, that is going to be the more stable one. So here you can see the carbocation that is forming on this carbon, which is not having any kind of stability because it is just secondary only. No, not secondary. The carbocation forming is primary, and it is not. There is no stability here. And here it is secondary carbocation. It is comparatively more stable than primary. What about here? Here you can see this is not going to do substitution reaction because this lone pair is in conjugation. Lone pair. Okay, I will take another color. So because this lone pair is in conjugation. Lone pair is in conjugation. Now this also won't be giving that much. Now what about the last one? Here it is what? Here it is secondary only. Carbocation forming will be secondary carbocation. But what is the important thing? Here the carbocation will be involved in involved in the conjugation, that is this carbocation will be stabilized by the electrons from the benzene ring. So this is going to be the more stable carbocation, that is benzyl carbocation. See, this carbocation is stabilized by the delocalization of electron from the benzene to the carbocation. So this is going to be the most stable one. Clear? And also it is secondary. This will be also doing the hyperconjugation. Going to the next question. Which will be the product through SN1? Yeah, which will be the product through SN1? This I have discussed in the class. I think without any doubt, I think you can give me the answer.
Option C.
Option C, very good, option C, because here the carbocation will be present in the ring. Whenever carbocation is present directly in the ring, in a strained ring, then that will be giving what? That will be doing ring contraction, and due to the ring contraction, there will be formation of cyclopropyl methyl cation, which is very stable due to dancing resonance. So this is the answer. Now, yeah, this one. Major product in the following reaction. I think we already discussed this one. Okay, this is, yeah, already we discussed this one. Sorry. This one. The compound C7H8 undergoes the following reaction. Yeah. Go through it and let me know the answer. Got the answer? Or shall I solve it? C7H8. Okay, we need to know what is this one. That we can understand from the product. So, yeah, from the options we can understand. Everywhere the product is toluene. So, which means this C7H8 is, surely it is the benzene derivative, that is toluene, CH3. Now, this one treating with the 3Cl2 in presence of what? Heat. What is this one? Halogenation, free radical halogenation, and that will be completely replacing the hydrogen and will be making the CCl3. Now this one on treating with what? Br2 in presence of Fe. What it is? Br2 in presence of Fe. What it will be doing? Electrophilic aromatic substitution. But my question is, where it will be substituting? Ortho or para position? Where it will be substituting? Ortho or para position? It is CCl3. CCl3 is what? Electron withdrawing group. If it is an electron withdrawing group, what will be the product? Ortho product or para product? Para product. Very good. Para product, are you sure? Are you sure para product? Or meta product? Ortho, para and meta product. I think I said only the two options, right? Ortho and para. What is the product? Ortho, para and meta. Which is going to be the most stable one? It is meta, because electron withdrawing group, no. Electron withdrawing group will deactivate the ring, which will leads to the substitution in the meta position. Now the last one. Zn bar HCl. Zn bar HCl. What it is doing? What it will be doing? It's a special type of selective reducing agent. It will be reducing the CCl3 completely, and we will be getting the final product CH3Br. Yes. Got it, Sakshi? Any doubt in? It's a special reducing agent. Just note it down. It will be completely reducing the CCl3 and will be converting it into the toluene with a meta bromo product. Okay. So remaining few more questions are there. Do you want me to solve it, or shall we finish this class? What's your opinion?
I will try.
You will try. Okay, yeah, you can try it, all the questions, and its solution also I have added. If you have any doubt, you can go through it. Okay, and if you still have any doubt, you can just contact me through WhatsApp. I will be clearing it. Okay. So that's all about the today's class. We are winding up the section. Next class we will be dealing the another organic chapter, that is alcohol, phenols and ether. So all of you just go through the chapter and have a good understanding of it, so that we can do the crash course very easily and smoothly. Okay, thank you all of you. Thanks for joining. Bye.